Hello. Hello, Android makers. Welcome to our talk. I have an announcement to make. You know that there's no lunch at this venue, right? We have to go and find lunch somewhere else. So this talk is titled Dinner for Two with Gemini, but I'll make it Lunch for Two with Gemini, takeaway or restaurant. I am Maia. I work at Conto as an Android engineer, and with me I have a co-speaker and colleague.
Mahya Habibi.
So let's go. Where do you think we should go for lunch?
I don't know, I'm starving. I'm craving beef carpaccio on a terrace.
That sounds fantastic. In fact, that looks so delicious that I think we can't wait for that. We have to have takeaways right now.
But didn't you say you want to cook more at home?
I want to cook more at home, but there is no way that I can turn this cucumber into a delicious dish like that. But you're the local. Can't you help us out?
Okay, let me check the Google Maps and see if we can find a place to go from my saved places. So the problem that we just role-played here with Maya is the problem that I encounter a lot during my daily life. I don't know where to go from my saved places. Should we go to this place? I don't know if it matches our mood. Or this place, if they have a pizza or a terrace.
But hang on, can't you search your Google Maps?
Well, it kind of works, but it's not searching through my saved places, and that's the problem.
Okay, I think you used AI to solve the problem, right?
Yes, exactly, of course, and I did it in a hacky way, like always.
Why is it hacky?
Well, I use the Google AI SDK for Android to be able to quickly plug it into my Android app and just communicate with the Gemini models. And here's the big red caution in the GitHub repository. The Google AI SDK for Android is recommended for prototyping only. But anyway, I will tell you my solution. So first, I had to get my saved places on Google Maps. For this, I use the data portability API. You see here in the response, there's the URL property. Now, from this URL, I had to somehow figure out the coordinates of the place. This is also super interesting to know, but I won't bore you right now with the details. Let's say we have the coordinates. Now, with the coordinates, I can use the places API to fetch the places details. In the places details object that I receive, there are so many information like the reviews, the features of the place, like if they serve beer or if they have a terrace, and a lot of information. And I save all this information into a room database on my Android app, on my Android device. And this is another solution this is another reason that my solution is hacky, because everything is happening on the client side. So anyway, now that I have my data ready, I can go to the AI part. The data that I want to provide as the context to the LLM. Now for the AI part. First things first, I have to write a good prompt. What do? I go to the Google AI Studio to be able to quickly iterate over my prompt and see how the configuration changes, the tweaks that I do here changes the response of the model. Here I can switch between the Gemini models, I can tweak the creativity level, I can turn on the structured output and provide it with the JSON schema that I want to parse on my Android app. And this is super important. And the last step here is to simply copy the code, and now we go to the Android side. And pretty classic, create a Gemini service and paste the code here. You see in the generation config property, there's the response schema that I've set, the JSON object that I want to parse on the Android side. So at this point, I have all my data ready, and I just need to connect everything together. So the solution is as easy as this. I have my data, I verbalize my craving, Then I write a good prompt for the LLM, and then I send everything to the LLM. The result is I end up at the right time, at the right place. Another reason that my solution is hacky is that I'm providing the LLM with its context through the prompt. It's one huge chunk of text with no filtering or shortlisting that I'm sending to the LLM. So it sometimes might get confused and just can't figure out a good result. And also from the cost point of view, it's not super efficient. And so what I'm trying to say here is that it's super easy to take advantage of AI and be creative and have fun and also build something that it's useful, even if it's only for you. So my theory is just do it and just hack it if you have to.
Do you think we can see what it looks like?
Yes, let's go. But before that, I want to show you a screenshot of the landing page.
Okay.
So here, when you first open the app, there's the big sync button, and when you click on this, you see this loading for some time, because it's fetching my saved places from the data portability API, and then fetching all the places details and inserting it to the room database. Here, you enter your craving, you hit go, and then you're recommended with this place from your saved places. And if you hit on the Google Maps, you see it will be from my saved places that I've saved before.
Can you show us your prompt?
Okay, so here's the prompt. You're an assistant to help users find the perfect cafe or restaurant or any place they are craving from their saved Google Places list. The user will describe what he is looking for, and you will find it. And then I'm providing it with the huge chunk of data, the details of its saved places, and I'm telling it to return it. And another thing that I can show you is the response schema that I talked about earlier. So here I'm providing it to the Gemini service that, okay, I want JSON, and this is my schema that I want to parse in my app.
But you know, I have a different problem to you.
Yes, how did you solve that?
Okay, let's have a look. I'm going to up the ante and connect to my personal device. The first thing that I need to do is I need to generate a token. Because like your solution, my solution is also hacky. I'm using a REST API, and to be able to access the Gemini API, I need a token. So there's a script in my repo to generate the token. Wait, did I get a build failure there? No, build successful. Ha, okay. Where was the red? We can ignore the red.
There's an error here.
Oh wait, did we type things here?
Yes, I think so.
Okay, right. Pair programming.
Yeah.
So for you, I have two solutions. I have one solution that also uses the LLM on the cloud, and I have a on-device solution. We're going to look at the cloud one first, but let's say I have in my fridge a cucumber. And now on the cloud, what should we eat?
Let's see. What do we have here?
There's
Pasta?
no cucumber in the pasta.
No.
No.
Here.
That one. I'm from Berlin, we'll have doner. Okay, come a bit closer. All right. So I'm taking a photograph. What it's doing now is it's converting that image into bytes and making a byte stream. And since I'm talking to the Gemini APIs are multimodal. So you can add images and you can add a prompt. So I have a prompt, I have the ingredient, and what do we have here? Vegetarian halloumi kebab. Okay, there we have some sliced cucumbers. We have red cabbage. This looks fine. That looks like a delicious. Wait.
Did you tell it to be vegetarian or not?
I did. Let me show you how I can show you how we set it to vegetarian, but let's look first. Okay, so, ooh, go away, Johan. I have steps here to make this dinner. And I've got the groceries that I have to go and buy, and hopefully there's no cucumber in the grocery list. Okay, that's great. So this puts me in a situation where I can go shopping for the ingredients and then cook. So how did it know that I was vegetarian? Good question. First, let me copy this title. I have here a settings screen. And in my settings screen, you can choose what you want. And in fact, you saw there that it said no onions. I didn't check now if there were onions in the recipe. But we'll check in the next recipe. And this settings dietary preference object will just have a two-string method that will output a string, and I will add that string into my prompt. Now let's look at the on-device solution. So that solution using Gemini is multimodal, and you can add an image and send an image up to the cloud. The on-device model that I'm using is the Gemma 3 model, the 1 billion parameters one, because it's small and it was one that was easy to fit onto the phone. It has a problem. It has two problems. It has three problems. But the first problem is that it's not multimodal, so I can't give it an image. So I'm just going to give it, what I'm going to do is I'm going to give it the title. Did they see the recipe? You saw the recipe, right? Okay, cool. All right. So I'm just going to give it the title of the recipe. I'm going to submit. So now it's taking time. Why is it taking time? Because it's loading that LLM file from the disk on the phone, and it's querying the LLM. It's using the media pipe libraries, the inference part of the media pipe libraries, and it's trying to come up with a recipe on the device. No internet involved. Perfect demo for Wi-Fi on the internet, but yes, it is not a speed racing. Oh, not too bad. Vegetarian halloumi kebab. Fantastic. We've got a reasonable recipe here. 2 large cucumbers, 250 gram. Okay, ginger, mint, cilantro. This actually looks quite delicious. I don't see the little breads. You know, the kebabs usually have a bread part to it. I don't see the bread there. And also there are these strange little stars over here, because that's the second problem with these on-device LLMs. I can't ask it to give me JSON. I can't ask it to format the output. I can try and coerce it into giving me JSON in the prompt, but that's really unreliable because it keeps forgetting to close its brackets. Also, I have the grocery list, and here you can see the formatting isn't so good because I'm not getting JSON back. I'm getting Markdown back, and I have to get the Markdown into my views. Right. So let me show you the prompt. The prompt is the same for both the solutions. You are a hungry home cook. And as Maia said, if you just change something in the prompt, you get completely a different response. And without this first sentence, the recipes were quite convoluted and difficult to cook and might have taken a long time. Given the image of a takeaway dish, the on-device LLM doesn't care about that sentence. Write a recipe that can easily be made at home and include the following ingredients, which I have in my pantry. That's where the cucumber goes in. And then here you can see the dietary preferences. The recipe title should be adding the recipe title. And so you combine the ingredient, the recipe title, the image into the prompt. And like Maya, I had generation config object. My solution, in fact, uses Ktor and uses a straight REST API. That's why I had to generate the token, and it hits the Vertex AI API surface. And so here I have a response MIME type. So for my online, the one that I'm talking to Google on the cloud LLM, I can tell it I want JSON, and I can build a schema in the same way that you built a schema. But the local one calls the local LLM using the inference libraries. Let me open the imports for a moment and you'll see. Okay, I've abstracted it away inside a factory. And then I have this really nasty parse function. So for sensitive audiences, I will hide it again quickly. It's a very naive and it's a very hacky solution, but for the demonstration purposes, that's what I have. I think we need to go back to the slides, and then we can explain a bit how everything fits together. Okay, back up, back up, back up, back up, back up, back up, back up. Right. So, this side is Maya's solution. Gemini, it's the LLMs are running in the cloud on Google CPUs using Google's memory here. There's REST interface here, and your solution uses Google AI SDK for Android. It's really easy. There's AI Studio, google.com, where you can try things out. In Android Studio, there's a wizard, and there's an SDK, so it's quite easy to plug and play in that. My solution, one of my solutions, also accesses this API surface, which is the Gemini AI API surface. And I'm using Ktor in here, using a REST interface, which is why I needed the token, straight into the Vertex AI surface, API surface. Why did I do this like this? Because it's quite clunky. At the time when I started experimenting, there was no SDK, and the only way you could get at Vertex. What's the difference between the solution on this side and the solution on this side? This side solution is the one that's meant to go to production. It means they're going to bill you. It means it's not free for experimentation, but it's the one that if you want to ship your app that you would use. In the meantime, there's a Firebase SDK that you can use to access this same path. But of course, there is a different solution. There's another solution using the Gemini Nano model. This is on device. No internet, you're not hitting any LLMs on the cloud. The LLM sits on the phone. There's one LLM. It's shared, multiple different apps can use the same LLM, and it comes with the phone. So I don't need to download any file. But there's a problem. So it's one shared model. It's only available on Pixel 8, 9, Samsung, whatever the version number is. Do you have a phone like that? Okay, so that immediately means you're limiting your users. Only high-end devices can use this. And because of that, and because it was early access, I didn't explore that solution. But what I did explore was this solution. Also, on device, no internet. The LLM runs on your phone using your CPU and your memory, and you access it through the media pipe libraries. The other benefit is this Gemma 3 model is what they call open weights or open source. So what's the difference between Gemma and Gemini? Gemini is Google's closed source ones that lives in the cloud and Google looks after them. Gemma is a release version of their LLM that is open to the public. You can download it from Hugging Face or Kaggle or wherever you want to get it. You get the file, and then you just download it onto the device. In fact, if I didn't want to use Gemma 3 there, I could have used another LLM which I found on Hugging Face, which is small enough to fit in there. But at the moment, the Gemma 3 models are the most effective. So download to your device. There's one of the things. So for this to work, you actually have to have that LLM, those weights, on your phone. So either you've got to write in the app somewhere the screen that's going to go and fetch it, or you've got to have a way of shipping it with your app. And it's about this file is about 350 megs big. In our case, it's a hacky solution. So I just ADB push and put it in a place where I can see it. It's the 1 billion parameter model, and it only does text-to-text. And there's no cost, because you're not hitting the API, so it doesn't cost anything, right? I say this, so you don't need any internet, and this is perfect for a solution if you've got private data on your device, and you don't really want that data to go out. So say, for instance, you are, I don't know, someone gets a legal letter and they don't understand it, and you want to have an LLM to explain the letter to them, but they don't want to send the legal letter up into the cloud because it's personal. That would be a good solution for that. But it isn't really completely no cost, because you're using your device's disk space, which means you can download less apps and have less music on your phone. And you're using your device's CPU and memory, which means your battery is the one that's going to get drained. So you're subsidizing or paying for the LLM running. And the other big elephant in the room, which I cannot deny, is the question of hallucinations. So I gave it mushroom tostadas. I didn't give it the picture. The picture is for the other LLM. And what it's telling me here is that it wants to use 1 kilogram of cucumbers. 2 large cucumbers, about 500 grams each. Have you seen a half a kilo cucumber? I mean, I haven't seen a cucumber like that. And in the steps, all of a sudden now, it wants me to fry potatoes with these cucumbers. I don't know. I mean, I've tried frying cucumbers, but it actually becomes quite a weird, slimy mess. I don't think that that's a good idea. And sprinkles for garnish. I don't know what sprinkles it was referring to, but it's sprinkles for garnish. So how do you get around this? What can you do to improve this? Because you will have the same problem with the Gemini Nano because there's one LLM, and those LLMs are general purpose LLMs. They can do a lot of things. They can translate things into Chinese, but maybe they can't write a good recipe. Well, you would need to get some good recipe data, and you need to find a way to change that LLM so that it writes better recipes. And one of the variables that you have access to in MediaPipe is this LoRa parameter. And you can do, what you can do with LoRa is you can tweak the values inside the LLM, and then it will give you better results. But I can never remember what LoRa stands for. Can you remember?
I guess low rate adaptation.
Low rate adaptation. The crux of it is that it makes a really small amount of data that you can use to tweak all of the parameters inside the LLM. I haven't seen any Kotlin code that does this, though. I've only seen Python notebooks that create this LoRa, but I've seen the Kotlin code where you can add the LoRa adaptations. The other problem with the Gemma model is the question of structured output. Now, structured output is important for an Android app because you need to get the data out and get it back on the screen. And so for structured data, you can see here, we have this issue here where I was parsing and I got the parsing wrong, and I put the stars for the bullet list that I got from Markdown into the amounts there. So what can you do to get structured output from a model like this? Well, you can write a really hacky, super annoying, error-prone parser, because this is my parser and it clearly hasn't got all of the things in it yet. But there are other solutions. You can do something which is called retry-based structured output. Big word of mouth, but what it means is this. You start with a prompt, you send it to the LLM, you get the output out. And before you give that output to the user, you check it. And then you say, okay, it's got too many stars in it, or whatever your rules are for your structuring. You add what you wanted to change to the prompt, and then you run it again, and then you check it again. Now, you can see here, this thing can carry on for a long time. Sometimes it chases itself into loops and never comes out again, or sometimes it does this multiple times. If you needed to do this on an LLM that was charging you per prompt, your bill would go up. If you're doing this on an on-device LLM, the time would go up, because every single time you hit it, you need to wait for that prompt to come back. So this is one mechanism that you can use. There is another mechanism that you can use, which is called structured generation. Okay, this is going to get a little bit technical for a moment, but I'm sure you can stay with me. You take the prompt, you give the prompt to an LLM. How LLMs work is they give you out a set of probabilities of what the next token is going to be. What you do is, before you actually use the token, you look at the token, at the probabilities and the tokens, and you say, it's trying to put an illegal bracket in here. We just delete those probabilities out of the things that are coming back from the LLM, so that the output probabilities can never be wrong, because you're checking against your schema at this stage. And what you can see here is that you don't have that multiple prompt loop, and then you get the correct output over here. The problem for me with this is, I don't know how to get there in the code. I don't know how to get in there where the LLM is giving me out these probabilities so that I can apply the thing that will structure the output. I might not have dug deep enough. Maybe there are some libraries, but that's... So again, I've seen this written up in Python examples, but I've not seen it in Kotlin yet. Okay, end of the technical session. What's next for us? So now we're going to do some user tests. Who would use Maya's app? Hands up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We need 20, because we need 20 testers, right? 20. Okay, I think you have enough testers. What do you need to do to get your app onto the Play Store?
Okay, so first, super easy. I use the Google AI SDK, which had the big
Firebase one.
No, the Google AI SDK,
okay,
which had the big red caution in the GitHub repo. I can switch it to the Firebase Vertex AI SDK, super easy, one-liner. And the other thing that I would do is probably to build a brag system and insert all the places detail into a vector database and then somehow feed it to the LLM. This I don't know yet. Like, I have to study, but I know there's a way.
Okay.
How about you?
All right, we'll do the same user test. Who wants to cook at home? Who needs groceries to know what to cook at home? No? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, not quite enough users, but if I give you some stats about how much healthier it is, maybe I'll have more. But let me tell you what I would need to do next. So let's see. For the online AI solution, I would need to figure out that mess with the token. So I would not use the REST APIs. I would also use the Firebase SDK, and then I would do that as well. But the problem with the online one is they're going to charge me, and they're going to charge you as well.
Oh, yes.
Yes. So we need banner ads, right?
Yeah, I guess so.
Okay, so maybe I revert back to the on-device one. If I go back to the on-device one, I have to figure out the structured output piece, and I have to figure out how to tweak it so that it's not going to ask you to cook 200 kilograms of cucumbers with your meal. Okay, so that would be. So it sounds like we do need some other form of monetization or ads in this app. So what did it cost?
Okay. So for me, it was €3.55. And it's because of my huge chunk of prompt that I'm sending to the LLM. So if I improve that part, then the cost will be lower as well.
Okay, so this cost represents what we were using when we were testing. So it's like one user. So if you think you're going to have 1 million users, you need to be able to pay that for 1 million users because it's just Maia testing our app. Okay. And in my case, it was 6 US cents because my prompt was much smaller. Okay. And what's next for you? Because you've seen all of this, and hopefully you're as excited as we are. There are 2 repos, completely open. You can scan the QR codes. You can see our hackery in there, and or possibly see our solutions in there. That's also okay. Then we'll stop early if we don't have any questions. You can also find us afterwards if you have questions for us.